Hey class, Mr. Husted here, talking to you today about Chapter 6, Lesson 5, using proportionality theorems. So we have a few more proportionality theorems to add to your list, and what that's going to help us do is solve for missing sides. Okay, so the first one is the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two, then it divides the two sides proportionally. So as you can see here, if this side and this is parallel, then the ratio of this side to this side will be the same as this side to this side. Okay, then they have the converse of that. So if we have the ratio here that is proportional, then these two lines then are parallel. Okay, so we're just going to put that into use right now. So they want us to find a line segment. In the diagram, we are given this information right here. We know that these two lines are parallel. They want us to find this missing side right here. They want us to find QR. Okay, so the way we do that, however you want to set that up, it doesn't matter to me, but we set it up as a proportion staying on the same side. So I'm going to say, we'll call it x over 9 equals, and it needs to come from the same triangle. So x is on the same part as 4, so 4 will be over top of 6. We're going to do our cross multiplication. We're going to get 6x equal to 36. We are going to divide both sides by 6, and in this case we are going to find out that this side is equal to 6. So the missing side, QR, is 6. So we do that. We can do that by using the first theorem there at the top of the page. Okay, let's talk about it in a real-world situation. Okay, so we have a shoe rack shown. AB over here is 33, so I'm just going to fill in the information I have. BC is 27. Let's see, CD is 44. Not going to be able to see red there, so here's 44. And DE is 25. Okay, they want us to explain why the gray shelf is not parallel to the floor. So basically, we need to just prove that that gray shelf is not parallel to the floor. And how we do that is by the converse of this. So basically, we're going to set up our proportions. We're going to see if they equal. If they equal, then it is parallel. If they do not equal, then we can just simply say they are not parallel by proving that the proportions do not hold true. So however you want to set this up, we'll stay on the red side first. I'm going to say 27 over 33 is equal to 44 over 25. So the very first thing we're going to have to do is we're going to have to cross multiply. So whichever way you want to go first, we're going to go here and here. 27 times 25 will give us 675. And then 33 times 44 gives us 1,452. I don't think those are equal to each other. Therefore, they are also, because they're not equal to each other, that means that this and this are not parallel. Okay, remember, we have to have an equal number on both sides for it to be parallel to the ground, or in this case to the bottom of the triangle. Alright, go ahead and flip over. We got two more theorems to talk about here. So if three parallel lines intersect two transversals, then they divide the transversals proportionally. So we have our three parallel lines, we have our two transversals. What we're saying is that this and this ratio from here and here would be equivalent to here over here. So it's kind of the triangle theorem. So basically, the parts of the transversal cut by the parallel lines would be proportional to each other. So they're talking about, we'll just say A and B, and then you would also have A and B. We could set those up as a proportion, and they would be equal to each other. Okay. The other one here is if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So AD over dB is proportional to CA over CB. And we would kind of know that because if this bisects right here, means it cuts into two equivalents, then these angles are also going to be the same. So the angle, so we have proportionality taking place there. So let's use that here. Okay, so in the diagram, angle 1, angle 2, and angle 3 are all congruent. Okay, we are showing that they are all congruent. 1, 2, and 3 are all congruent. GF is 120, DE is 150, and CD is 300. Find the distance HF between Main Street and South Main. So let's locate HF. Alright, so basically we need to figure out what HG is first. I'm going to call this our X. But because we have our three parallel lines, 1, 2, 3, and we know that by the converse of corresponding angles. Okay, they're corresponding, they're in the same spot, they're all equal, making these lines all parallel. Because we know that, we can set up a proportion. So what we'll do, and just to double check over here, we will go back up to our theorem here. And so we have our three parallel lines, and so we have the transversal parts should be proportional to each other. So if we have our three parallel lines, let's see here, 1, 2, and 3. So this should be proportional to this. So I'm going to say 150 over 300, and make sure we're coming from the same part of the transversal, should be equal to, so if 150 is here, I'm going to go here with 120, 300 is here, so it's going to correspond to X, cross multiply, I'm going to get 150X equal to, let's see here, 36,000, divide by 150 on both sides, and we should get X in this case should be equal to 240. Okay, unfortunately that is not where we have to stop, because that is not entirely what they are asking for. What they are asking for here is what is the entire length from here, from F to H. So they want F to H, so we would just have to take 240 plus 120, and that's going to give us a total of 360. So in this case it's 360 yards. Okay. Last but not least, use theorem 6.7. Alright. Okay, so in this theorem, from the previous theorem, this 6.7 talks about how if an angle bisects, then the base sides are proportional to the sides over here. So what we're looking at here is these two sides we're going to set in a proportion. Now the whole thing is 15, and we know the one side is X. So if that one's X, then the other one has to be 15 minus X, because we know the total length and we know one of the lengths, so to find the missing one we would just subtract it. Side corresponding to X is 13, the side corresponding to the other side is 7. Here's where it gets tricky. You do your cross multiplication, you're going to get 7X, and then what you have to do is 13 times 15 and 13 times X. Okay? So 13 times 15 is 195. 13 times minus X is minus 13X. We want to get everything over to the other side, so we're going to add 13X to both sides. We're going to get 20X equal to 195. Divide both sides by 20. In this case, we are going to get X equals 9.75. So we have found the length of RS, because RS is X. X is equal to 9.75. So lots of information we've gone through today, but it's all about proportions and knowing what is proportional with what. So make sure that you understand what we can set proportionally equal to each other. If you do not understand, I definitely encourage you to rewatch this video because some of the wording can get confusing. But if you have questions, please bring them with you to class, and we'll see you then.